Okay, what is Gauss' law? Now, Gauss realized that he can define a quantity called electric flux. Electric flux with the symbol phi, in which it is technically the number of electric field line crossing a surface. So let's say you have a surface, a flat surface like this, and some electric field line are crossing it. You can count how many lines passing through this surface, and that becomes the flux crossing this surface. Of course, the angle between the surface and the electric field lines are important. The size of the surface is important. This area is important, and also the magnitude of the electric field lines. So he realized that the electric flux is proportional to the amount of the electric field. He also noticed that this electric flux is proportional to the surface area. And also he realized that this flux is proportional to the angle between the electric field lines and the surface. Now, typically we define a direction perpendicular to the surface. Some people like to call it n, as normal to the surface. Some people like to call it a hat, means it's the surface area unit vector. And so you can define a vector for the surface area, which is equal to the magnitude of that surface area times the normal to that area. And he realized that this flux is proportional to the cosine of the angle between the electric flux and the normal to the surface. So, for example, in an ideal situation where you have a uniform electric field and there is an angle between the electric field and normal, like this, then the cosine of theta defines how much of that flux, how much of those electric field lines are passing through the surface. That was the first step. So we combined them all together, and he said this flux then would be equal to the electric field times A times cosine of the theta between them. Which, if you remember the vector analysis, you know this is technically the inner product, the two vectors, electric field and the surface area. Okay, now this was derived when A is flat and E is uniform. What if A is not flat? What if E is not uniform? If you have a point source of charge, then the electric field is not uniform. It's diverging, and the further you are, the smaller it is. If you draw a surface around it, like this, the surface is spherical. It's in a spherical shell and it's curved. And so the key here is the trick that we use an infinitesimal area called dA. It has a normal direction, which is radially outward. So I can define a vector dA, which is technically the magnitude of this little tiny dA in the n hat direction. And then I can claim that the amount of electric field which passes through this little tiny dA is kind of uniform. There's a little tiny e passing through it, and it's uniform. And so I can calculate, instead of the entire flux, I can calculate the little tiny flux passing through this little tiny surface area as E dot dA. And if I want to know what is the overall flux, the total flux, then I'm going to integrate over the entire surface on this little tiny fluxes passing through little tiny surface areas, which becomes the integral over the entire closed surface E dot dA.